Okay, this is Chapter 2, Section 7. We're dealing with transformations. We're going to start moving around those graphs that we looked at in Section 6. That's why it's so important to know what those graphs look like. Okay, some basic transformation. If you add something next to x, it's going to go left because it's always opposite what is in the parentheses. So plus normally would be right. Since it's in parentheses, it's the opposite, which is left. Minus is normally left if you subtract. But in this case, since it's in parentheses, you're going to go right. Outside is normal. Plus is up, minus is down. So suppose you have x squared. Okay, if you're going to sketch that, hopefully by now you've memorized it, and you have a parabola touching 0. Okay, minus 3 is going to go right 3. So I just count right 3 and draw the graph. Plus 2 is going to go, start here and just go up 2. 1, 2, draw the graph. F of x minus 3 is going to go down 3. So I just count 1, 2, 3 down. So you just need to know inside and outside, left and right, up and down. Outside is up and down. Inside is left and right, except it's backwards on the inside. Now, if you put a number in front of x, it's going to make it taller and wider. Bigger than 1 numbers make it taller. Less than 1 positive numbers make it wider. If you put a negative in front of the x in the parentheses, it will reflect across the y-axis. If you put a negative outside your function, it's going to reflect across the x-axis. Okay, taking a look at the same things we had earlier, x squared. Sketching that one, again, touch 0, 0, drawing a parabola. 2x is going to be taller. Okay, if it's normally this wide, it's going to be taller because basically your slope has changed. So it slopes up faster. Negative reflects across the x-axis, so instead of going up, it's going to go down. So that's just more transformations. Okay, symmetry. Symmetry has to do with the same on both sides of something. If you put in a negative x and nothing happens, then you have y symmetry. If you have put in a negative y and nothing happens, you have x symmetry. And if you change both of them, you have what's called origin symmetry. It's the same on both sides of the origin. Okay, suppose you have x squared plus x to the 4th. If we plug in negative x, it gives you x squared plus x to the 4th, because the negatives disappear when you square them in 4th power them, so there's no change. So there is x symmetry. Or y symmetry, rather. If you put in a negative y, you get negative y equals x squared plus x to the 4th, which is different than you started with. And then if you change them both, you get negative y, x squared plus x to the 4th. So that is different than you started with. So in this particular case, there was no change for this one, which means you have y symmetry. Okay, x squared plus y squared equals 1. If you change the x, when you square it, it comes back positive. If you change the y, when you square that, it comes back positive, so there's no change. If you change them both, they'll just both revert back to positive, so there's no change. So if there's no change, basically it has x and y and origin, or origin symmetry is a default way to write that. Now, even functions and odd functions, you can just look at the powers. Even functions have all even powers. Odd functions have all odd powers. If they're just mixed up, it's neither one. So suppose you have what we had before, x squared plus x to the 4th. Those are even. X squared plus y minus 2x. Look at the x powers, a 2 and a 1. So that's neither one. It's not even and it's not odd. Because you have a 1x squared and a x. That's a even and an odd power. So that concludes this section.